Hey, what the heck? What the heck? Sorry guys, yes, I'm back from the teacher's workshop. How? Mtutuzi, you should be running along to take this jacket. Yes guys, I'm back from the teacher's workshop and they told us that paper too. It is very much important. Thank you very much, Mtutuzi. Yes guys, so that's why today we'll be moving into map work. Mtutuzi, don't be wearing my jacket. No, don't be wearing my jacket. You are making map work extremely difficult for me. No, guys, map work is very much not difficult. Don't let Tutuzi fool you. Alright, guys. So today we'll be understanding what is map work. Before we understand map work and map work calculation, we first have to understand the word map. And when it comes to a question of what is a map, you simply say it is a small piece of paper which represents a larger area of land and its physical features such as roads, churches, schools, and even bridges, water, agriculture, everything like that. It represents the map or the land and its physical features. It makes you understand that in a particular area, how does it actually look like? How does that area look like? How are the houses distributed? How are the roads distributed? All right, let's write down our definition. What did we say? We said it is a small piece of paper which represents what we call a larger area of land and its physical features. Yes. Yes, guys, remember, I do not choose which marker comes out of my pocket. If I decided to write with the red one, it was not by choice, but then the ancestors let me. Alright, guys, now we understand. Small piece of paper which represents a larger area of land. So a small piece of paper which shows you and makes you understand how a particular land looks like. A particular area simply looks like. Yes, there are two types of maps in which I definitely know about. Because I'm from South Africa, we use two types of maps. Whether you are in grade 9 or whether this is your last year and you want to find yourself in one of the economic sectors, which we learned about before this lesson. Alright guys, let's move through. We said there are very much two types of maps, right? There is what we call our orthophoto and what we call our very much topographic. Yes, guys, these two types of maps, you definitely do not have to have your favorite. You have to definitely know them all. When we talk about the orthophoto, we definitely talk about close-up. This is close-up publication. Orthophoto, close-up pictures. This is close-up landscape. So if this is a close-up landscape, this will definitely tell you that this will be a far-fetched. It will be a higher altitude than this one. It is very much higher altitude than very much orthophoto. And what else? Meaning if it's a close-up, it definitely means that it is taken within the range, right? Meaning the equipment or the GIS systems which are used to take the landscape pictures of an orthophoto are your very much drones, your planes, your helicopters, and your water balloons, right? So it is very much your drones. It is your drones, your planes, and definitely your air balloons and stuff like that. Those are the GIS systems which are used to collect the data to show you the map of an orthophoto, right? And obviously when we move here, if this was drones and planes and air balloons, this one has to be satellites. Here we are speaking about satellite. We are speaking about far-fetched. This is geography. If you know one thing, you definitely know the other. Close up, very much higher altitude. Drones and planes, there you have your flipping satellite. Yes. And Mnumzane has been bloody screaming a lot, but then he has not touched the most important thing, which is called the scale. Yes, this is our scale, guys. What is a scale? A scale, it is a tool used to tell us the actual distance on the ground from the very own map. So if you have your map, the scale which you will find there will tell you the actual distance on the ground. So when we're looking at the topographic map and an orthophoto, we have different scales. Why? Because of they have obviously different picture qualities or different picture distance. So if this one it is taken much closer, that definitely means the scale it is much larger. But then this one, because of it's taken very much far away, the scale will be smaller to be able to accommodate a lot of object and physical features which were obviously taken. Because of this one obviously takes a lot, so it has to have a small scale so we can obviously shrink the real distance on the map. So in a topographic map, the scale which you find on your map, when you're looking at the map, guys, I do not have maps right now. Maybe learners for 2025 will have ones, but then because of you are very much lucky to have Mnumzane, I can edit. This is a topographic map I'm speaking about, and when you are looking on top of there, we can see a scale. What does that scale say? That scale simply says 1:50,000. Yes, guys, it simply means 1 centimeter equals to 50,000 centimeters. 1 centimeter on the map equals to 50,000 centimeter on the ground. So usually when it comes to a scale can be represented in 3 different ways. A scale can be represented in 3 different ways. There can be this 1:50,000, which is obviously our very much ratio. This is our ratio, 1:50,000. This definitely looks like a ratio. And we also have a scale which is represented in a fraction form, which is 1:50,000, right? 1:50,000. This is our very much fraction, right? This is our fraction form. And remember, these two are obviously numerical ways to show a scale. The ratio and the fraction form are the numerical ways to show the scale and to represent a scale. Meaning if they are numerical way, that definitely means they have to be a written way or a verbal way to say 1:50,000. And you have to obviously say it. When they ask you in geography, what does 1:50,000 simply means in words or verbally? What will you say? You will definitely say 1 centimeter on the map. You have that 1 centimeter on the map equals to 50,000 centimeters on the ground. Guys, I didn't make it short like I did before when I said 1 centimeter equals to 50,000 centimeters. When we come to the ways of writing, you have to write it by word by word. Maybe you did not see properly there, right? So what I want you to understand is that when it comes to writing it on a verbally form, you have to write it like this. 1. Write your 1 of the O-N-E. 1 centimeters on the map equals to 50. You write your 50. You write your 50,000 centimeters on the ground. You write it by weight. You write it by weight and you get your marks. And it's very much nice. And there's also our last usually scale. This scale, you find it on every map, whether topographic map or orthophoto. This scale looks like this, guys. This scale looks like this, right? You find the scale all the time, guys. This scale is very much discrete. You would find it like this, right? And it's like this, and maybe it say here kilometers, and say it says meters. And this scale, it is called our line or linear scale. Right, this is our line or linear scale, right? This is, it might say 0, 1, 2, 3, 4, 5 kilometers, right? And here it will obviously divide the 1,000 meters. Usually there are 1,000 meters here. From 0 to the last point equals to 1,000 meters usually, and they like to break it into 10 units, where you will find your 100 meter here, your 100 meter here, until they are 1,000, because of it has to be obviously 1,000 meters, right? This scale, it is usually used to obviously measure. I use this scale a lot. The problem is that I do not have a map right now, but then you can obviously take what we call your very much piece of paper. This is close application book, guys. You surely have seen it for the first time. We have written a lot have been written here. A lot of classes have been done. Yes, guys. So you take a piece of paper. Maybe they say this is your very much map, right? This is your school and this is your house. Tell us the actual distance, not actually calculating it. Just tell us the distance by not calculating it. So maybe they put a point here, they put another point here. You put your paper from point A to point B. You put your paper, right? Let me find a paper. Sorry, guys. Okay, I found a paper. Guess which paper I found? It's $1, right? So you put your paper from point A to point B. Look at that. It just meshed like I definitely knew what I was doing. So now you know that from point A to point B, it is the actual distance from your school to your house. You will put it on your line scale. From where? From 0 to where? To here. So now what do we find? We find that from your school to your house, you walk 2 kilometers. Damn, this guy definitely walks. You walk 2 kilometers. Yes, guys, these are the kilometers you walk. But then if you want to know the actual distance, this is where you will be having to calculate. And we are not there yet. This is where you have to multiply by 500, multiply by 0.5. This is where it comes in. But then maybe let's say our very much distance, it is here. So this is our home, right? This is our home. This is where the point is. Then our dollar here, maybe it is somewhere within this line, right? This is where our dollar stays. Then we put from 0, and maybe this is where it ends. This is where our dollar ended, right? So now we know the distance. It is like 1 kilometer and something. There is a something here. Then what do? We put our dollar again from that 1 to that something. Now we know that we have that 1 to that something. We want to find that how many kilometers and meters does he have to walk, right? We put it here. We find 1, okay, is to this point. Then we place it here. From where? From our 0, right? Going this side to find our meters. So we put it there. Then we know with, oh, all right. So this is definitely our 100 meters. We remember it is divided into 100 meters because of there are 1,000 in total. 100 until the last 10, right? I didn't draw until the last 10, but then remember it usually divided to 10 blocks to make 1,000. Now we know that he walks 1 kilo. Now we know that he walks 1,1 kilometers from school to home. That's how you use your linear scale, which you find on a map. Yes, guys. All right. Then we obviously have to know that orthophoto also definitely have its own scale, guys. We cannot forget about that. Its own scale, guys. It is our 1:10,000. Yes, guys. And we obviously have spoken about this. 1 centimeter on the map equals to 10,000 centimeters on the actual ground. That is your answer. And it can be also represented in the fraction because of we can see it is represented in a ratio and also in a written form. You can write it 1 centimeter using the ONE equals to 10 using the TAN, using the TEN. Yes, guys, this is your marks. This is how you first understand map work before we move into much deeper calculations. All right, guys, before I finish the lesson, I have to continue to what we call contour lines. Make sure that you like this video, subscribe to my channel. Why? Because of we need to buy the maps. We can't be editing for 5 days Okay, I've decided not to wipe a lot because of contour lines are not that difficult, guys. All right, so we obviously have our first map here. This is our orthophoto. Let's say this is our orthophoto, right? So our orthophoto obviously has what we call contour lines, right? And let's use the orthophoto to have contour lines which are much closer together, right? Let's use them. Let's say these are what we call contour lines which we find on this particular orthophoto map. Not to say on all orthophoto map we find contour lines which are closely packed together. No, this is just an example for us to better understand what it means to have close up contour lines, right? So this is an orthophoto, and usually in an orthophoto the contour lines have the contour intervals of between 5, so they are not that far away from one another, right? So let's say this is 295, so this will be 290, this will be 285, and this will be 280, this will be 275, right? These contour lines are in the interval of 5, right? They leave a space between of 5. They use 5 to separate each contour line. Yes, guys. What are contour lines? Contour lines are usually lines which join places of equal height, right? They are lines which join places of equal height above sea level. So these lines are joining. So if this line is joining this area right here, this definitely means this area and this area right here, they have the very same height. They are in the same height above sea level. This one and this one, they are in the same height, the same level. But then what does it mean when the contour lines are closely packed together? Because if we started with that, the contour lines are closely packed together. So if the contour lines are closely packed together, that is definitely what we call your homework. Everyone definitely knows that. I'm not going to be saying it. No, I'm not. Then we are going to be moving to what we call our topographic map. Yes, guys, this is our topographic map, right? And our topographic map also has contour lines. Yes, it does have its contour lines. But then let's make these contour lines like this. These contour lines are very much far apart, and the contour intervals on the topographic map is different than the contour intervals on the orthophoto. Remember, the orthophoto 5 is between. There's 5, 5, and 5. But then in a topographic map, 20 intervals are 20. So it's 20, 40, and 60. 20, 40, 60. Right? So this is how they look like. Remember, you can find the contour lines that are far apart from one another, whether in orthophoto, and you can also find the contour lines that are closely packed to one another in the topographic map. But then it doesn't matter whether they are closely packed together, the intervals will be 20, 20, 20. Here also, doesn't matter whether they are far apart, the contour line intervals will be 5 and 5 and 5. Remember, they are far apart from one another because of the land. It is very much gentling. They are closely packed because of it is very much steep. So if you find a land on the map where there are contour lines that are closely packed together, you must definitely be like, that has to be a mountain. It has to be steep. People must go up. Why do you think about the gradient when you think about a contour lines? Because of we said it on a definition. We said contour lines are lines which join places of equal height above the sea level. Meaning the lines that join equal places of the same height. It has always been about the height when you think about contour lines. Whether it is descending or whether it is increasing, the contour lines must be closely or must be far apart to one another. Okay, guys. So now we know the contour lines definitely has to speak about the height of an area, right? And the scale definitely has to speak about the what we call the distance on that actual area on the map. Yes, guys. And now, because of we have a clue of what map work is. Map work is not calculation. Map work, it is the love of map, understanding maps. I just do not have I do not have a map, so we could obviously look at the symbols. You must analyze the map. You must enjoy the map. Because of that, things show you where you could actually travel. Because of we are living in a place we do not know how we are actually structured. I'm living here in Meadowlands. I do not know how actually this area is structured. But then because of now we do have phones and maps and stuff like that, we can obviously use the satellite from a topographic map to find the map and to look at how we are actually structured. Okay, guys. So remember, if you are zooming in just a little bit on your map in your phone, just kancane, that means, and take a screenshot, that means we are taking an orthophoto. But then if you are doing a deep zoom, a deepest zoom, that means you are taking a topographic map. Yes, guys. This has been a much nicer lesson. Make sure you like this video, subscribe to my channel, because of after here, we now move into map work calculations. Okay.